Right, hello. GCSE Foundation. We'll go over what lesson 1 was. We started off with types of number, different types of numbers. Right, then, so we had whole numbers, which are called integers, for some reason or other. And these can both be positive, 42, 612, minus 6, minus 12. So they can be both positive and negative. We had decimals, which were 2.3 minus 0.4. Anything with a decimal point in it, really. It doesn't matter whether it's positive or negative. It doesn't have to be a whole number, then a decimal. It can be 0.4. Fractions. And 3/4, 2.5, minus 6 and 5/7, something like that. All sorts of fractions. So this is a standard straightforward fraction. This one here is a mixture of whole numbers, integers and fractions. So this is called a mixed fraction, and there you have a negative mixed fraction. Now when you have the fraction, we'll get onto this later on in another lesson. If the number at the top is bigger than the number at the bottom, it's called a top heavy fraction. And percentages, we'll see another one. Percentages. And there's a 20% discount on something, or you get a 3% pay rise if you're lucky, and you can have minus 15% when you've got a reduction as well. So all sorts of percentages, and we are going to have to be able to effortlessly, however you say that, between decimals, fractions and percentage. Effortlessly. Wow. Let's hope it's easier than it is to say. Right, what we got there? We got square numbers, haven't we? We got square numbers, squares, and this is denoted by a little 2 at the top. So this means this number times itself 2 times, so that will be 4 times 4, which equals 16. And you've got square roots. Now this is the opposite way round. So if I put the square root sign over the 16, we're looking for 2 numbers that multiply together to make 16. They've got to be the same number. So we know it's 4 by 4, isn't it? 4 times 4. So the square root of 16 equals 4. We've got cube numbers, cubes, and a little 3 at the top now instead of a 2. So this means we've got to multiply this number. I'll show you another number because we don't want to get mixed up with which 3 we're on about. So we've got 5. So it's the big number multiplied by itself 3 times, and that equals 125. So 5 cubed is equal to 125, and go the other way around, the cube root, so the cube root of 125. Now to differentiate between a square root and a cube root, we just put a little 3 there. Nobody ever puts a 2 there because we just make the assumption it's a square root. But the cube root is 125 of 125 is a number that multiplies by itself or with itself 3 times to make that number, and 5 times 5 times 5 equals 125. Therefore the cube root of 125 will equal 5. Now let's have a look at this. We've got something called surds, and if we know that the square root of 16 equals 4 and the square root of 25 equals 5 times 5, which is 5. There's a lot of numbers in between here, so this is where the surd comes into it. If we want to know what the square root of 20 is, we don't know. It's not a whole number, it's not an integer. So that awkward square root is called a surd. It's a square root. Any square root that doesn't come out to be a whole number is called a surd. Then we've got rational and irrational numbers. So all the numbers we've said above can be divided up into two sort of camps. One is rational number, and this is anything that can be written as a fraction or a whole number, and this is anything that can't be written as a fraction. An example is right, let's see, 2.5 can be written as 2.5. Yeah, so that's fine. So a decimal there can be written. A third is a fraction. Now the third is actually 0.3333, never ends, yeah, but we would rewrite that as 0.3 with a little dot on the top of the 3 to say that this is a recurring decimal, and this recurring decimal can be written as a fraction, so therefore it's a rational number. And 25% can be written as 0.25 or 1/4. So it can also be written as a fraction. Now the numbers that can't be written as a fraction, really the only one that we're interested in or we need to worry about is this, the Greek letter pi, and we use that when we're doing calculations with circles. And pi is a 3.142, I don't know, 5890, blah 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 blah, and that number goes on forever, and this cannot be written as a fraction. Yeah, you can get very close to it, but no, it can't be, because it never repeats itself. So that's an irrational number. Then we moved on to some very, very basic addition. So we did 24 plus 49, and you start from the right hand side and you work left and you go 4 plus 9 is 13, and you carry 1 over, so you've got 3 in the unit column and 1 in the tens column, and 2 plus 4 is 6, plus the 1 is 7. So that's addition. Subtraction, 73 minus 41 is easy. Yeah, start from the right. 3 take away 1 is 2. 7 take away 4 is 3. Let's make that a bit more difficult, shall we? 73 take away 44. Again, keep them in columns. Keep them in columns. Now 3 take away 4 we can't do because we'd end up with a -1. So we don't want to be doing that. So what we need to do is borrow 1 from this next door number. So if we borrow 1 off there, we make that 6. And what we're doing, because the 7, which is now the 6, is in the tens column, what we've done is actually borrowed 10, not 1. So we put the 10 in front of there to make that 13. So 13 take away 4 is 9, and 6 take away 4 is 2. Even more strange is 201 minus 46. Yeah. Now, 1 take away 6 we can't do, so we have to borrow from next door. In the tens column there is nothing. So we have to go left to the hundreds column and borrow 1 off of there. So we borrow 1 off of there, which is 100, and we stick it in there to make that 10 tens, as it were. So that we got there. So now we've got 10 in this column, we can borrow 1 off that and put it on there. So that makes that 11. So 11 take away 6 is 5, 9 take away 4 is 5, 1 take away nothing is nothing. So we can, oh no, it's 1, isn't it? Yeah. So that's 155. So that's subtraction. And we'll do this with negative numbers and decimals and all sorts of things later on, but just get the hang of this. Then we did multiplication. Now 23 times 42. Yeah. Now again, keep them in columns, and we still work from the right hand side. So if we look at this bottom number, this is 42. So it's 40, which is 4 times 10, and 2, which is 2 times 1. Yeah. So that's how that 42 is made up of 4 lots of 10 and 2 lots of 1. And what we're going to do is multiply this top number by the 2, and then multiply this top number again, but this time by 40. So we're going to go 2 times 3 is 6, and then 2 times 2 is 4, and that's fine. Now we're going to multiply by the 40, there, the 4, and this is one column to the left, therefore we need that so that we get our answer in the right place, in the right column. And this here, this 0 that we stick in, is called a place marker. And we go 4 times 3 is 12, so that's 2 with a 1, and 4 times 2 is 8, plus that 1 we carried is 9. Now we've got this little sandwich thing that we need to add up together. So 6 and 0 makes 6, 4 and 2 makes 6, and 9 is 9. So our answer is 966, and that is how you multiply. If you had 23 times 40, there's nothing in there to multiply, so we move straight on to the 4 there. Place marker, 4 3s are 12, and 4 2s are 8, plus 1 is 9. So we'd get that. So if there's nothing in that column, move along to the next one, and it's much easier. Multiply, that's okay. If you say you were multiplying by, I don't know, multiplying by 8, and you didn't know your 8 times table, just for the moment, 8 and 8, just write your 8 times table in the margin or something. 48, 56, 64, and so on and so forth, until you get the right number, and then you can multiply easily. Now multiplication is quite important. Wow, that's very loud, I'm sorry. So turn me down a bit. Multiplication is very important. I'm just testing the microphone. Okay, you might want to move it down a little bit more there. Oh, try that. The sound does vary on this thing. Do apologise if all a bit crackly and stuff, but it's better to be too loud than too quiet. So what we're going to do, division. Okay, now division, lots of dots. Now this is I'm using something here to explain this called the bus stop method, and it's because it visually looks like a bus stop. There's a bus stop. Now if I want to do I don't know, 192 divided by 6. Yeah, so what we do, we put the 192 in here, and we put the 6 out there. Now I'm not going to give you an example where we've got bits left over and what have you, because we can either have a remainder something or a decimal something. I'm just going to do it where it works out exactly. So what we do with a 6, we divide it into each of these by in turn. So this time we're going the other way, left to right. So 6's into 1 don't go, so I'll put a 0 there just to remind us of where we are in the sort of column scheme of things. So because it didn't go into the 1, we still have to take note of that 1, and now we go 6's into 19. 6's into 19 go 3 times, because 3 6's are 18, and because 3 6's are 18, we've got 1 left over from the 19. So we put that 1 on there, And now we go 6 into 12 is 2. So your answer equals 32. You can drop the 0. That was just to keep us on the steady path. Right, so that's division. Let's do another division, yeah? So let's do 315 divided by 7. Okay? So right, so now you've got to know your 7 times table, haven't you? So imagine you didn't. 7, 14, 21, 28, 35, 42, 49, that's 7 sevens. That might be enough to get us going. So 7s into 3 don't go. 7s into 31 go 1, 2, 3, 4. Yeah? So 4 sevens are 28. We've got 3 left over because it's 31. Take away 28, that gives us 3. So we put 3 in there. And how many 7s go into 35 is 1, 2, 3, 4, 5. So we put 5 there, and your answer is 45. So that's just a little bit of multiplication, division, and stuff like that. Now, next we went on to highest common factor. First of all, we're going to explain what a factor is. Yeah, a factor is just a number that divides. Divides I before E, except when you're writing it over the top of each other, and there's E. Yeah. Shall I write that again? Because that's rubbish. Sorry, everybody. But it's only lesson 1. Give me a chance. Divides. That's why I do maths, because I can't spell. So, factors, factor, and that. What does that mean? A factor is a number. A factor is a number that divides into another. Right, got there in the end. Sorry. What does that mean? Well, say I've got the number 10, yeah? And the factors of number 10 will be 1 times 10. That's how I can make 10. Or I can do 2 times 5. So the factors of 10 are 1, 2, 5, and 10. See, it's any number that will... Actually, this multiplies into that, but 10 can be divided by 1, 2, 5, or 10. That's how we get that. So let's do the factors of 16. So I'll write 16 and put a lines so that I don't get the factors muddled up with the actual number. And to make 16, I do it this way. I go 1 times 16, and I give myself a big gap in the middle to write the other ones. Or I could go 2 times 8, or I could go 4 times 4. No need to write the 4 twice because we're only after the number. So 1, 2, 4, 8, and 16 are factors of 16. Let's do 25. We're not going to get many there, are we? So it's 1 times 25 and 5 times 5. So the factors of 25 are 1, 5, and 25. Now, when we are looking for the highest common factor, which can be abbreviated to be the HCF, what we're looking for is a factor. We're going to get 2 numbers. We're going to get 2 numbers. We say that we're going to get 40 and 16, right? So you get 2 sets of numbers, and you're looking for a factor that is common to both 40 and 16, and we're looking for the highest one that is common. So everything that multiplies to get 40 is 1 times 40, 2 times 20, 4 times 10, 5 times 8, and no more. So there's all the factors of 40, and 16 is 1 times 16, 2 times 8, and 4 times 4. So the common factors are 1, 2, 4, and 8. And the highest common factor is the 8. So of 40 and 16, the highest common factor equals 8. So all you need to do is list all the factors of the two numbers and look for the biggest one that matches in both sets. That's all you do. Right, okay, next one up. Next one up is the lowest common multiple. No, this is the other way around here, yeah. The lowest common multiple, or the LCM, if you want to do it that way. Now, we're going to have two numbers, and the multiple just means a times table. Times table, whoops. And say we've got a 6 and an 8, yeah? We want to find the lowest common multiple of 6 and 8. So all we do is a 6 times table. So we go 6, 12, 18, 24, 30, 36, 42, 48. That might be enough actually. And the 8 times table is 8, 16, 24, 32, 40, and 48. So the lowest common number is the first number you get that matches both, yeah, which in this case is 48. I'm sure that if you went all the way up, if I doubled that number, I'd get 96. If I double that, I get 96. So this would also be a common multiple, but the lowest common multiple is the first one you come across, and is pretty easy to miss. Yeah, you don't get ones. Yeah, that's only in the highest common factor. Now, common multiples and factors. So let's go back to factors. Yeah, so we've got factors. So let's do factors are all the numbers that multiply together to make another one. So if we list the factors of 4, right? The list the factors of 1 times 4 and 2 times 2. List the factors of 5, it's 1 times 5. List the factors of 6, is 1 times 6 and 2 times 3. The factors of 7 is 1 times 7. Now you see these two numbers, 5 and 7, they only have factors of 1 and themselves. And they are called prime numbers. So prime numbers have factors of 1 and itself. And the only caveat we've got here, the number 1 is not prime. It doesn't count as a prime number. Don't know why, but it just doesn't. So some prime numbers that we've got are going to be 2, 3, 5, 7, 8, 9, 11, 13, 17, 19, and 23. So there's the first 9 prime numbers. Now you see that nothing multiplies into these numbers apart from 1 and itself. So these are prime numbers. Now if I go back to these factors, because 1 doesn't count, if I ring round all the prime numbers, yeah, these are what are called prime factors. They are factors of a number, but they happen to be a prime number. So that's that. So we'll be looking at finding prime factors. Now we're going to use something called a factor tree. It's like a family tree. Yeah, it's like you've got the parents, and then you've got the children, and then you've got the children there, and then you've got the grandchildren. Yeah, that sort of thing. Yeah, it's a simplified. There's no marriage and divorce and second marriage and all that kind of complication with real life. But yeah, it sort of looks like a family tree. So if we take 36 and we want to what they call is express. Now express just means write the prime factors of 36 using the factor tree method. That's the sort of question that they would put for you. So what you do is you find any two numbers that multiply to make 36. Can be anything you like. 2 times 18, 3 times 12, and so on and so forth. 4 times 9, anything. It doesn't matter because the answer will always be the same. So I'm going to go 2 times 18. Now, remembering that list of prime numbers, whenever we get a prime number, put a ring round it and stop. Because factors of 2 is 1 times 2, factors of 2 is 1 times 2, and you go on and on and on and get nowhere. So now we look at the other number and we say to ourselves, or somebody else, I don't know, can we factorize this number? Yes, we can. So we can factorize it further. We've factorized the 36 by going 2 times 18. Let's factorize the 18 by going 2 times 9. Now, there's another prime number. Ring it round. Now we can factorize the 9 by going 3 times 3. And 3 is a prime number, so ring round and we've finished. Yeah? So 36 is 2 times 2 times 3 times 3, and 2 2s are 4, 3 4s are 12, 3 12s are 36. So just by using the prime factors of the number 36, we can actually multiply them all together to make 36. Now if we'd have chosen a different number, say 3 times 12, that's a prime number, and that's 3 times 4, that's a prime number, and that's 2 times 2, they're prime numbers. And you see, again, we've got 2 times 2 times 3 times 3. So it doesn't matter which way around we do it. Doesn't matter. Now, the final bit of this kind of thing, using factor trees, is we're going to find the express in prime factors in what's called index form. Now, index form. Do you remember squares from just now? We said 5 squared is the same as 5 times 5. Now imagine you've done your little tree and you've done all that sort of stuff and you've worked it out and you've got 5 times 5 down there. So you go, oh yeah, that's 5 times 5. Now this is index form. Because we've got 5 times 5, it would be much neater to write it 5 squared. So we do the same thing as we did before, find all the prime numbers on the end of the little trees, branches or whatever, put them all in a row, and then gather them together in squares or whatever. If we had 6, oh no, that's not a prime number, is it? We had 7 times 7 times 7 as a result, then we would tidy that up to make it 7 cubed. So let's have a go at doing a factor tree with index form, and we'll do 420. This is huge, yeah, but this, when you use the tree method, this doesn't make any difference how big it is, yeah. So anything ending with a 0 can be divided by 10, so this is 10 times 42. Factorize this, 2 times 5, and look, we've got 2 prime numbers. 42 is 6 times 7. That's something to remember. 7 is a prime number, and 6 can be divided up into 2 times 3. So what we've got here is 2 times 2 times 3 times 5 times 7, and in index form we tidy it up a little bit and call it 2 squared times 3 times 5 times 7. And if you multiplied that all together, you'd end up with 420. That's it. Right. Now, last bit, to the power of 10. A bit of a misleading title because it's 10 to the power of something. Yeah. Now, this only works with tens. Yeah. So if we do 10 squared, that equals 10 times 10, which equals 100. And you see the number of zeros in the answer is equal to that little index thing. Yeah, the little square. So 10 squared can be written as 1 followed by 2 zeros. So 10 cubed will be 10 times 10 times 10, which equals 1 followed by 3 zeros. Yeah. 10 to the 8 will be 10 times 10 times 10 times 10 times 10 times 8 times. Yeah. So that will be 1 followed by 1, 2, 3, 4, 5, 6, 7, 8 zeros. Whatever that is. Thousands, 100 million. Yeah. Now, there is another one that comes before a square, which is just 10 to the 1. And that is going to be 1 followed by 1 zero. So if something is to the power of 1, it is itself. So anything to the power of 1 is itself. And it doesn't have to be 10 for this rule to work. We can have 16 to the power of 1, which equals 16. 7 to the power of 1, which equals 7. That sort of thing. Anything to the power of 1 is just itself. Right, I think that's covered everything that we did in lesson number 1. So I'll send this to you. Toot sweet, very quick. Okay, bye.